Hey everybody, I am very excited to announce the next summer edition of the Knowledge Graph Technology Showcase. These are all going to be my honest reviews of these tools and services, and there's going to be a summary slide at the end of each video, just like last time. So the technology that we're going to be reviewing today is... There we go. All right, so without further ado, let's go get started. Okay, so today we are going to be talking about a really cool visual tool. It's called Graphistry, and every time I look at the website, I have to say that I'm always mesmerized. I'm always like, wow, that's a really cool way of visualizing what data can actually tell you. And I also think this is really important when you're trying to translate the work we do in graph and in data science in particular to end users that may not be as familiar with this technology. All right, so I am joined with Leo here. So Leo, do you want to introduce yourself?
Thanks, Ashleigh. So this is a fun one for us. So I'm Leo, founder over at Graphistry, and so I started coming definitely from like the scientific space where we're doing high performance computing and visual analysis and security analytics over at UC Berkeley. And then with Graphistry, what we realized is we can bring GPU computing and visual and kind of more advanced visual analytics to everybody by running all this stuff in GPU clouds. And so we were pretty early to actually a lot of that stuff. So you might not have heard of Graphistry, but there's a good chance you've seen on Twitter some visualizations some of our users have done, or you might be a data scientist using things like GPU data frames, which was something that's NVIDIA's big project spun actually out of Graphistry itself. And so nowadays I get to work with people doing fun problems like security teams doing threat hunting, or fraud teams trying to find the bad guys, or like governments trying to find the really bad guys. On the other end, I think we were kind of mentioning the academic side. I think one of the wildest ones I was doing was helping folks look at mutations in cancer. That's when it gets bad, right? So graph is pretty exciting.
So Leo, let's jump in. I really am excited to see what you're going to show and some of the use cases that you're going to walk through for us.
And this one came from Project Domino, which is a medical misinformation project that we're running with a bunch of data scientists and researchers and things like that. So and actually all this stuff I should probably point out, if you go to graphistry.com, get started, you can actually get a free account and actually do a lot of this stuff for yourself.
That's amazing.
Actually, I should do a shout out here. So this project, this part of it was primarily done with a researcher called Cody Webb, and recently some of the results of his work was featured on HBO for their QAnon documentary series. And so episodes 5 and 6 are about revealing who the head of it is. And actually 1 or 2 years of investigative work leading up to that from Cody was actually the big insight for unveiling who that was.
It's fascinating. And there's a lot of cool things that you can do with some network analysis on who talks to who's being influenced by who, and some of that properties of people and linguistics is really cool. And I think that plays a lot into what you're going to be showing today.
Yeah, and actually the technique I'm showing here has become one of the staples for how Cody and some other folks in the group now look at misinformation, especially when you have a lot of text documents and you have to do the social data, but also the content analysis. So what we're looking at here, so we're inside of, we have a Graphistry session. What we're looking at here, what we did was we took a bunch of social, like we were actually looking at anytime somebody on Twitter mentions COVID or coronavirus or anything, we pulled that out. And so we're getting like 100,000 of these things every day. And then we just pulled out a bunch of different folks who are talking about different conspiracy theories, and then we ran them through an NLP algorithm and kind of put them in X and Y space. And so every here is like a different account, and you can kind of see the different things they're talking about. And so this is a very classic way of, if you have a lot of text and you want to just map it out, but it's not very graphy, right? This is just like a two-dimensional embed, right? And there are a lot of different ways of doing this, but what gets really cool is what we started to then do is, once you have any embedding like this, a really cool trick for basically any machine learning pipeline is to connect the nearest neighbors. And so instead of having kind of logical relationships, we actually have fuzzy relationships. And so these accounts, and it's almost like a fingerprint. Like imagine like two sound waves that kind of feel similar. So these accounts are kind of talking about the same things in the same relative intensity. And that actually gives us a really powerful graph. And so now we can actually start really using Graphistry here. Like we already have it just as an interactive environment. I'm going to share a couple, playing with a couple things here. So actually what's going on behind the scenes is kind of fun is you're actually not, you don't just have data in the browser, you're actually connected to a GPU session in the data center. Actually, a big thing we're working on this year is to get streaming data so that right now, like for example, you're seeing this clustering running. We're actually streaming live from the server to the client. So this actually is kind of live, but we want the data feed itself to be live. So where I want to go with this is let's just do some quick like Tableau style playing with the data, except for instead of with pie charts and stuff, we can actually see our entities. So what I'm going to do is I'm just going to color based on speaking QAnon, like that ends up being one of the more prolific ones. So I'm just coloring each account based on how frequently they talk about QAnon. And so this gets pretty fun, right? Like where let's say we're looking at this cluster over here. Let me just size it a bit. This like all of these accounts are kind of talking about the same things. So it might be a bunch of sock puppets that are sort of, or like running off the same script or whatever. Like it might be, bots or whatever. But what's interesting is they're pushing the same stuff and the same intensities. Clearly, one part of it is more QAnon than another. And maybe it's because they're involved in different campaigns, or maybe it's like there's a funny retweet relationship. But what gets cool is we can actually start seeing this. And so just to kind of put some numbers on this, the database side, I think like, I don't know if we have like 100 million, 200 million like tweets that we're kind of, at least at that point in time, that we're working with. And then on screen, we pulled out about 5,000 from using an analytics to kind of say which are the ones interesting here. And then on screen, once we have those 5,000, we do the nearest neighbors. We got about 97,000 relationships on screen. And then when I was doing that like real-time clustering and kind of seeing these patterns, that's using all that subset right there. And now we're able to see they're kind of like each one of these clusters is sort of based on that sort of content signature are kind of like different almost misinformation campaigns or groups pushing the same stuff. And they all have different shapes and things. We can now use more normal tools to like, drill in on like select these, see, okay, these are very little on QAnon, which is pretty clear, but maybe these, anyway, we can drill in whatever. So this technique, first of all, this has been just generally useful for us, this pattern of doing machine learning embedding and then using the nearest neighbors to extract the relationships. We'll look at it. We'll even put it into a database, and then that'll actually be the relationships in the database that we track, things like that.
So let me repeat back then. So it seems like you're doing the embedding here, you're getting some of those nearest neighbors, and then you can take that nearest neighbor and put it back into the database. Is that accurate?
Yes, that's super useful as like an analyst, because as an analyst, you might want to put entities you found back in, but actually these extracted relationships that you found is super powerful. So maybe that's a good transition of like, how does the actual analyst workflow work? So you're getting that once we have the data, like how we do, but a lot of our work is actually about how do you go from raw data or database to like we don't really think of ourselves as a graph company or a graph visualization company. We think of it more as like an investigation company. So like, how do you go all the way from data through that full process and probably iterate?
And that's what was so appealing to me too when I first came across what you guys were doing, because that's the trend is, okay, let's make a pretty picture so people can just like figure out what graph does. But yours is not, it's digging deeper, and it's actually providing insights. You hear some people talk about insight engines, but this is actually starting to capitalize on that. And it's not just what you're doing. I mean, it's almost like you were you had your finger on the pulse of the stuff that was going on that was going to enable this to work correctly. So, the stuff with NVIDIA and the other things that are going on out there, including in understanding the usefulness of graph, has, I think, translated into this amazing tool that you guys have.
That's probably a good transition there of like, so we work with different kinds of users. And so when we're doing, especially when we're dealing with a lot more data, that's either somebody really expert in the data, and they may or not be able to code, or they might not have time to code. And so they like having this scalable environment. But then sometimes, and so we found those types of folks are like, imagine like a deep like fraud analyst or somebody like that, like just looking at all this stuff. But at the same time, we find they're often nowadays paired with like a data scientist, or it might just be the data scientist doing it. Like we were talking about the embeddings. And so what we found, I found that a lot of graph tools don't really get how people actually work. Like that.
Yeah.
And so one of the important personas we find is actually the data scientists nowadays. Like if you have a data-driven organization, you might have one of them, and then or you might have 10 of them, and they're kind of like a lot of people are relying on them. And so something we kind of did early on and drove a lot of our understanding is actually open source, so Graphistry. And basically our question was like, in like one line or a few lines of code, could we take any data source and turn it into this?
Nice.
And like for whatever your database or data source, like we've been kind of working on that in different ways. And so maybe as two quick examples, like let's say you have like a text file of like a traditional, let's say it's already a graph. So you have like, source to test. So it's literally, that's it. You're like load in the file into a table and then get in that table and plot it. That's it. You're done. Right. And behind the scenes, we'll kind of do stuff like, if I got rid of this coloring here, so let me just get to that. See how we kind of, by default, we'll just do the coloring for you. Things like that.
Cool. So how would I interpret the colors if I haven't set up that filter?
Yeah, so if by default we'll run the community detection for you, and we'll just color by communities for you. And we do a pretty weak one. And then if you want to, before you get into actually graph analytics, generally we find people just want to paint by the data. Like in that case, I want to see QAnon. And then if you do want to paint by the actual analytics, like this, instead of QAnon, maybe it's like a risk score, then you can do that too. The other one actually I want to show, and I'm going to come back to this one in a little bit, is something called hypergraphs. And this is, I think, like one of the coolest things in graph, and also one of the worst names.
I would agree with you, yeah.
And so I'm guessing some people listening to this know about it, some don't. I find out it's one of the things that I've used the most and have to explain the most. And hypergraphs are great when you have more like entities, like IPs and users, alerts, things like that. And so in this example, let's say we have an event log, like some logs of like IP addresses and alert names, and it could be an IT log or a security log, or like doesn't really matter. It might be product. You have people clicking on stuff, and you're doing user analytics. You could just kind of pick which columns you want to turn into nodes, and that's it. Like that's really
nice.
It, right?
And I do have to say that this is one of the things that also I hear the most people complain about is, okay, I have all these tables, I have all of my data that is not structured as a graph. How do I get insights out of it without having to go the full graph route? And I think this is that happy medium where you're actually getting some value out of things because you actually know your data, your tables very well. Yeah. If you can cobble that together in a way that's going to give you your answers, it may not be the most efficient and it may not be the most cost effective. There's other things that you can do to fix that. But I think that this gets you that answer if you need to at least test it out and kind of kick the tires a little bit.
Yeah, and this actually also is a good point about the whole thing about persona. So this stuff is cool if you're already using like Jupyter notebooks or things. But a lot of people are working out, like they might be like a really good security analyst or something like that. But they don't, like writing in Python or data. Yeah, like, and even if they could, it's going to take a while. So I just did something ridiculous behind the scenes. I just uploaded the file and did nothing else. And that wasn't not a graph file. That was just like logs.
Yep.
And this is what we got out of it. Like we got something with with a timeline on screen. We see, an IP address, an alert. This case, we're actually looking at a honeypot. And so in honeypot, if for folks who aren't coming from the security side, that's when you have like a server that sort of might have some vulnerabilities in it. And then you just kind of expose it to see if you have any hackers on your network who already are in, and you kind of trick and lure them in. And we can kind of see all the people hitting them. We can actually let me color by the side because I have no idea what's going on.
It's almost like another way of describing a honeypot is like if you're, think of a spider sitting in the middle of a web and you kind of like feel out like if something's happening. Yeah. That's sort of what this is doing in a visual way.
Exactly. And so what was cool here is one is I was just by using the hypergraph, like it just picked out all the entity values, and then whenever there's an event, we're kind of linking them together on the same row. They just get linked together, and we can kind of play with it. So for example, and we have a UI, like we'll infer the stuff by default, but like for example, right now we're looking at IP addresses and alert names. Other here as an analyst, I might want to care how they're getting in. So maybe web traffic is on port 80 and SSH logins are on port 22. So I might want to
So
add
you
that.
can you can customize the events that you want to trigger off of. Is that accurate?
Exactly. You could do shaping without any, you can do graph shaping without any coding. So we see this honeypot, like most of the attackers are coming in on port 445. So that's probably an API port. And I could very quickly make that insight now.
Well, and I think another use for something like this is if you want to test if graph is going to actually be a good solution for the problem that you're trying to solve, because it looks like a very quick take the data, plop it in, and see if it's going to actually, it's a good stress test, right? To say, okay, do I even want to go down this graph path? So I love that, because that quick visual interpretation is so critical when you're trying to make a decision to invest in something quickly or not.
Yeah, there's like will it graph, right? And then like it's like I have like two things. Like one is like, is there a graph here? And then the second is this is actually where the GPU stuff, and I should probably make a note about that, but like where the GPU stuff kind of, one of the nice things that comes in is sort of like just your data discovery. Because if you just get like a big log file or a big CSV dump from someone, there's probably a graph in there, but you need to figure out which. And if you on a normal tool, if you tried to put all the entities on screen, it would just crash, right?
But I'm so happy that you say that, because literally in all of the other technology showcased reviews that I've done, when they show visuals, I always ask how many things can be painted on the screen before it crashes. And there's always, well, it's a caveat, right? With yours, there isn't really a caveat, which is like, it blows my mind. And that I'm just so excited. Yeah. I'm so excited about this in general. Like I could just sit here and like be giddy about it.
Yeah, I'll say we raised the bar. I'm not going to say we're working at, like we're trying to push to the billion level on screen, but that's going to be a while yet.
That's so crazy, but so amazing.
And actually, as an analyst, I actually nowadays think about graph often as almost like as correlations. Yeah. Like the relationships are kind of like correlations. And so when I'm doing like an analysis, I want to figure out what are the correlations in the data. And often the first ones are really dumb ones. It's like, yes, every user has a name and an ID. So I quickly see it on screen, and then I want to get rid of one of them.
100%. So what I use things like this for, and I might be checking this one out to do this too, is I'm dealing with a lot of topical data. This thing is about this other thing. And there are those super concepts that you don't actually want in your graph when you're actually doing runtime application of graph, because it slows down when you're actually doing a query, and it's a no-brainer. So all people are human. Yes, thank you. I got it. So now with this uncovers that a little bit easier, rather than having to do all those queries to kind of find out where those super clusters are to eliminate them from your sample size.
Yeah, and often when I'm working with a data set that has like a lot of columns or some of these super nodes, what I'll do is I'll just like build out like a filter list to kind of like figure out what's kind of what I don't like there. And then as you're seeing as I'm going along, the filters or exclusions get added to the stack. And then after I'll go to like a notebook or whatever to actually codify them. And so what I want to point out is, and actually almost kind of like a shout out here, when you run Graphistry like a private server, we do come with Jupyter, but the interesting thing is up here is this where it says Rapids. And sometimes we're doing graph work visually, and sometimes we're doing it just pure at the code level, right? And we come with this GPU environment and this ecosystem called Rapids, and where today, if you are a notebook user, you might use something like Pandas or NetworkX, things like that, right? So this is a fun. So Rapids, where we have all the GPU drivers and libraries installed for it. Graphistry libraries like optimized for it. Most of the time, I recommend TriHub just to play with the data. But then as soon as you have any sensitive data, what we generally see people is like once they feel it's important or whatever, they'll launch in AWS or Azure. You get everything. And then when we work with more like, let's say, a government team or a fraud team, then they might want to actually run their own server. We have like Docker images. This stuff used to be super hard. Like,
Docker has changed the world, certainly, because even if you're not dealing with super highly sensitive data that you and some of your users in government and security, I mean, with GDPR and some of those other privacy things, I think a lot of people, even if they don't have something that's, critical to the nation kind of information, people are moving more towards, being able to do this. When I say on-prem, I'm talking about their private cloud. And I'm so glad to see that you have AWS and Azure.
Most people just start with one server. We have like a cheaper grade. A trick I like there is, and actually I do this with a lot of our users, is just have the server just auto shut off at like 5 p.m. or 3 a.m. or whatever. Just if you're using it for the day and not coming back.
Yeah, that's a good pointer. That's the bonus here, is if you want to try this out, if you want to just see if this is going to meet your needs, there are others, not mentioning names, that anything you do POC, you have to pay for. And it's like, well, you're asking me to pay for testing out your product. I understand sometimes there's no way to get around it because, people have to work on something to set something up. But this allows you to just dump in, see what's going on with a small amount of data that's not sensitive, and figure out if you want to continue farther. And I think that's fabulous.
We find that sometimes, people might start with one thing, like maybe you start with D3, like you try us out and you're like, no, I want to use D3, or I really like to do whatever. But then later you do hit those data sets and like, okay. And so we're like, we get it. So,
and I just a plug, having used D3 and other things in my past that do similar things to what you think Graphistry is doing, talking to the audience here, that stuff, if you're building it from scratch, takes eons, and then you have to maintain it, and then you have to make sure everyone understands the code base, and there's so much stuff that goes into that. Or you could use a tool like Graphistry that kind of does all that hard work for you, so you can just get to the problem that you're trying to solve instead of recreating visuals if that's not your main business.
Kind of what we've been learning is that, like, just as we could embed, Graphistry in a notebook, and it works with the whole PyData, data science pipeline you might be working. The cool thing with Plotly is that really only a little bit of code lets you make a few of those like easy buttons. And then, as you saw, you just need to get us a data table, and then we'll already give you something. And then you can kind of iterate there based on your user feedback or kind of as you go. And that really, maybe eventually you want to go to Plotly, or eventually you want to do a custom web app. But if you want to have something like, in 2 hours, or and actually have a full graph app in 2 hours that you already have sketched in a notebook, you can actually do that now, which is insane.
That's